In this lesson, we're going to be reviewing the graphing of trig functions. Let's go back and start about what is the definition of the sine function. Remember, it comes from the unit circle, and we had the right triangle where this is r, this is y, and this is x, and the sine of theta, where theta was right here, was defined to be y divided by r. And on the unit circle, r was always equal to 1. So we get this relationship that the sine of theta, or your angle, are the y values. And we concluded in a previous math class that it's a periodic function, that it repeats itself every 2 pi radians, or 360 degrees. It had a maximum value of +1 and a minimum value of -1. And you learn to plot the points. Let's look and see perhaps where that graph really came from. So looking at this unit circle where the radius is 1, and remember the sine is the y value. So what is the y value when the angle is 0? It's at 0. So what we're going to do is we're going to use this slider, and as we rotate around the unit circle, we're unwrapping that and graphing it out. So as we get to pi over 2, the y value is 1, so it's 1. As we go around and our angle goes from pi over 2 all the way to pi, we still have positive y values, but they are decreasing. Then we get past the angle of pi, and our y values become negative all the way down to -1, but then they're increasing, still negative, as we complete the revolution of the circle, and that is our sine wave. So the value when the angle is 0, the sine is 0. When we have pi over 2, or 90 degrees, we have a y value of 1, or a sine value of 1. At pi, it's 0. At 3 pi over 2, it's -1. And at 2 pi, back to 0. And then we connect these with a smooth curve as possible. And that is your basic sine wave. Cosine. We defined the cosine of theta to be x over r, and if r is 1, then we get cosine to be the x values on our unit circle. We still had a period of 2 pi, we still had a range of 1 to -1, but again, let's see where that unwrapping or the graph comes from. So remember, the cosine is defined to be the x values on your unit circle, so that x value is 1. So you might not be able to see it, but we've plotted a point up here at 1. And then as we rotate toward pi over 2, those x values are getting smaller. They've gone from 1, the x value here is 0, so we're decreasing. Then as we go from pi over 2 to pi, those x values are negative. It's going from 0 out to -1. And there we get that part of the graph. So we're rotating from pi to pi over 3 pi over 2. We're getting still negative x values, and they're going from -1 to 0. Don't look at the y values, the x values. So we're going from -1 back up to 0. As we're coming around the circle, those x values are positive, and they're going from an x value of 0 here to 1. And again, there's our cosine graph. When x is 0, the cosine of 0 is 1. When x is pi over 2, and I'm talking this is your x-axis, when your angle is pi over 2, your cosine value is 0. At pi it's 1, and back up to 0, back up to 1. So maybe you have or have not seen that, what we would call the unwrapping of the unit circle of how to get that sine and cosine. And why is it periodic? Because I would just be going around the circle again and again and again, and you would repeat that same graph. Now the sine and cosine are actually the same graph, they're just shifted by pi over 2 or 90 degrees. So let's talk about some other characteristics that you should be familiar with. You're going to have the general equation here, where A is going to be our amplitude. And that amplitude is the distance from the horizontal axis up to the highest point or down to the lowest point. Our vertical shift, meaning when we come off of 0, could we move that up and down? That's going to be represented by the letter D. If it's plus, it's up, minus is down. Phase shift, that is left or right, moving that graph. And that is going to be determined by C over B, this number divided by that number. And the period can also change. It starts out at 2 pi, but if B is something other than 1, it changes that period. Again, this is being taught as a review from a previous trigonometry class. So let's see if we're going to ask to graph the following over a 1 period interval. What I'm going to ask you to do on the test and the classwork is again to stay to 1 period, work in radians, and as we go through these exercises I'm going to show you what I want labeled. Right, so let's look at the amplitude, or the A value is 3. And the D value is -1, so our vertical shift is going to be down 1. Now at this point you may have learned a different way, and that's okay. I'm just going to go through the way I graph it. I take this, basically the angle of the sine, and I'm going to put it between 0 and 2 pi. So what that's going to take care of is my phase shift and my period. Again, you can go through do it separately. This is just how I do it. At this point you want to solve for x, so I want to subtract pi over 2. So that's 4 pi, 4 over 2, 1 over 2, that would be 3/2 pi. Then I want to divide everything by that 2, or multiply by 1/2. What that tells me, solving for x, lets me know that I'm going to shift the graph to the left pi over 4, so that's my phase shift. And again, you could have gotten that from C divided by B. And my period is from there to there. Alright, so how far is it from negative pi over 4 to 3 pi over 4? It would just be pi. And again, you could have gotten that from 2 pi divided by 2. But what I like about this is that that tells me where I'm going to begin my graph and where I'm going to end my graph in a 1 period interval. So I'm going to have my x-axis, there's my beginning, there's my end, and what I'm going to ask you to do is I'm going to label the tick marks on the x-axis, and I want you to have 5 of those equally spaced, the beginning, the end, the one in the middle, and then the quarter marks. So how can you figure out the middle mark? Well, you can find the average of those two. You can add them and divide by 2. So -1/4 plus 3/4 is 2/4. Take half of that is 1/4. So this is be 1/4 pi. And just stick the pi's back in. And then you need to find the middle of those. Well, negative pi over 4 and positive pi over 4, the middle's got to be 0. And at this point you can kind of see a pattern. I'm counting by fourths. So that was -1/4, 0, positive 1/4. So this has got to be 2/4 right here. 2/4 is the same as pi over 2. Okay, so that would be your horizontal axis. Now I'm going to think about, alright, at this point you can put your vertical axis anywhere you want to. Sometimes for me it's convenient to do it out to the side here. And since, let's see, I'm going to be down 1, I know my original x-axis was up here. So this would be at 0. So if I'm down 1, this is at -1. That's going to be the center of my graph horizontally. And then my amplitude is 3. So I'm going to go up 3 from -1. 1, 2, 3. And I'm going to go down 1, 2, 3. So this is what I want labeled on your graphs. The top, middle, bottom vertically. And then 5 equally spaced tick marks horizontally. Now let's graph it. All right, so we have the sine. So it starts on the horizontal axis at the beginning, then it goes up to its peak, comes down to the horizontal axis, goes down to the lowest point, comes back up to the horizontal axis, and then try to connect this as smoothly as possible. If you wanted to see what it would look like computer generated using a computer program, this is what the graph would look like. So you can tell that it is much shorter period than from 0 to 2 pi. We have a period of just pi, so it cuts it in half. And because of that amplitude is 3, it's very tall. So you can see the horizontal axis runs through -1. I'm up 1, 2, 3, down 1, 2, 3, and we've plotted those points. Again, not exactly to scale, because hand drawing, sometimes these numbers get so crowded together, you've just got to leave yourself some space. Let's go through the cosine graph. I am not going to ask you about the amplitude and the period and phase shift, but if that's something you're comfortable doing, then that's what you should do. I like to note that my amplitude is negative. Now, I know we can't have a negative, but what does that negative do? It flips the graph upside down. It rotates it, it reflects it across the x-axis. And I also like to know my vertical shift is up 1. And again, I take the argument of the cosine and put it between 0 and 2 pi. 0 to 2 pi was my original beginning and end. Now what are these other numbers going to do to it? So I'm going to add pi over 4. And then I'm going to multiply everything by 2. You do not have to do it this way. Your graph has to be my way. Right? So again, I know I'm going to start at pi over 2, so I have a phase shift to the right, and I'm going to end my graph at 9 pi over 2, and the distance between pi over 2 and 9 pi over 2 is 4 pi, which would be the period. And again, you could have gotten that from 2 pi divided by 1/2. So this time our graph is going to be stretched out further than the original cosine graph from between 0 and 2 pi. So again, I start out with my horizontal axis. I have my beginning and my end. And again, these numbers are pretty nice, but you've got to figure out what the middle is, and the middle of the middles, or the quarter. So what I do is I add the beginning and end and divide by 2, finding the average, or the middle. So 1/2 plus 9/2 is 10/2, which is 5. 5 divided by 2 would be 5/2. And then at this point you could do the same thing. You could add 1/2 plus 5/2 and figure out the middle of that, or kind of see the pattern. 1, 5, 9. What's going to go between them? 3 and 7. So we have 1/2 pi, 3/2 pi, 5/2, 7/2, 9/2. Now I'm going to put my vertical axis, and now I'm going to take care of all of this. So since I'm up at 1, I'm going to call this 1, and then I'm going to go up 2, and down 2. Right? So this was originally 0, and I've shifted it all up 1. But again, I just want the middle, the top, the bottom, and those 5 marks across the horizontal axis evenly spaced. Now I know I'm graphing cosine. I know it's flipped, so I'm going to start at the bottom. So here's my beginning point at the lowest point. Then I go up to the next quarter mark, goes to the 0, and then to the top, back down to 0, back down to the bottom. So we have something that looks like that. So for me, this line in the middle here is confusing. I would just rather have my middle, top, and bottom, and that's good enough. Again, if you want to see a computer-generated graph, here we have it. Matches pretty good. Again, this is not to scale, as in this is not the same spacing as your vertical axis. All right, so you can see that at y is equal to 1, if you drew that line, that it divides the graph evenly between the top part and the bottom part.